Hi everybody. Next we are going to discuss about the measurement of displacement using potentiometer. It is a very important topic. How we can using the potentiometer we can displacement we can calculate in the potentiometer. So first it will be calculate the displacement and vector quantity. Based on that we can calculate the potentiometer with respect to change the position of the body with respect to the particular point with respect to the body of the area. The difference between the coordinate of the 2 points, that is point A to point B to point C, like that it will coordinate the 2 points. Suppose here we take the point A to D. Suppose is another one vector, it will take as another displacement. So next, what's the measurement? What's the need? Why we go for this measurement in the sense? We can use the measurement like it's a force, stress, pressure, velocity, temperature, acceleration, whatever it may be. We can calculate many measurement, but the force, pressure, velocity in terms of displacement, it will be very useful. And how we measure the displacement, that's the main matter. Where we use the displacement in the transducer in the sense, convert the physical quantity into electrical quantity. That's the main important parameter. That is, the physical quantity, physical weight, the physical values is converted into electrical quantity. That is a very important of the displacement of the transducer. We have the two main parts. One is the sensing element or primary transducer. Either it may be a sensing element or it may be a primary transducer. Second one is a transduction elements or secondary transducer. Mainly primary transducer or secondary transducer. Here we have the sensing element. With the help of the sensing element, we can sense the quantity, and then transduction element. That's a transduction element. It will detect and then will give the electrical signal to the particular user. That is the main displacement. And next we move to the linear potentiometer. We have the potentiometer in the electrical device. It convert the variable resistance, like it's our resistance value. We have the variable resistance. Suppose you imagine this diagram. We have A, B, C. We have this resistance. This is called as a potentiometer. We have the slider point. We will move point A to point B or point B to point C. It will varying the potentiometer level. That's the important point. That the electrical distance, it will resistance where A to B have certain resistance, resistance point B to C have the certain resistance value. Based on that, it will moving. That depends upon the displacement. That's called as a linear potentiometer. We have the symbol of the potentiometer here. So we have the changing the values in clockwise and anti-clockwise. Then automatically the potentiometer having the varying the potentiometer resistive values. Here we have the symbol of resistance. Here we have the applying the external voltage. We have the, suppose we have the 28.3 volts and we have the 100 kilo of resistance value. Based on that, it will be varying the potentiometer level. That's the thing. So next one is this electrical circuit. We have the external source. In the external source, we have the points where we fix the gauge. Point A, B, C we have. So where we fix the gauge, depend upon the gauge, it will be producing the electrical output voltage. That's the main function. This is the three-dimensional view of potentiometer. So next one is the angular potentiometer. This is another one. So it may be a few degree to 30, that is 360 degree level we can mention. So it is a rotary level or it may be angular potentiometer. Based on that position, the potentiometer level will producing the frequency level and it will be having the resistance value here. Here you have the core and here you have the core and electrical signal we have. So moving of mechanical energy, that mechanical energy is converted into electrical signal. That is called as a electromechanical system. It's a positive inductive transducer. We call it as a positive inductive transducer. Moving at the position of the coil, it will be varying, it will be working. So that is the main function. So where left to right or right to left, where it will move, based on that it will producing the potentiometer. That is called as a electromechanical potentiometer. So next we have the LVDT, that is linear variable differential thermometer. We have the cylindrical transform the things. We have the iron core of the middle is available in the middle. So we have the displacement, what we have seen in the previous one, like it's a movement of displacement. We have the silicon and the silicon dioxide. The secondary primary winding we have. Based on that, the movement where it will be located, based on the movement, it will producing the output of the LVDT. That's the main thing. It may be a primary or it may be secondary. Based on that, it will move and it will producing the output. That is called as a linear variable differential thermometer. So we have the six important advantage of LVDT. First one is a linearity. It will have this a linear value, so it will change with very minimum level of L. That is called as a linear variable differential thermometer. And then infinite resolution, high output, high sensitivity, ruggedness, and less friction. There is no sliding contact. That is the main important advantage of LVDT. Yes. And then applications, we have some few applications. Mainly the LVDT mainly is called robotic cleaner, dollar bill thickness, and ATM machines, and hydraulic cylinder displacement, filmmaking machines, and testing of soil strength, and many applications we can use in the LVDT in